So in lesson 7.5, we continue to work with trig ratios. And 7.5 looks specifically at finding the missing sides using those trig ratios. So we can use those trig ratios, which we learned about yesterday, which were sine, cosine, and tangent, to find that missing information. So we've got four main steps here when we're given a triangle with some missing side lengths that we want to find. Our first step is always to label our diagram, which means that we want to mark off the angle that we are going to use, as well as those opposite, hypotenuse, and adjacent sides. So in my example here, I've got a triangle with an angle marked off with 63 degrees. I've got one side length of x, which we're trying to solve for, and another side marked off as 14. Right? So the angle that we're going to want to use here is 63 degrees because that is what's given to us. So just like yesterday when we filled in either angle A, angle B, angle C, whatever was given to us in our diagram, we're going to do the same thing here. It's just now we know the measure of that angle. Okay. Since we're focusing on that measured angle of 63 degrees, right, we're going to want to label the sides according to how they relate to that angle. Okay. So the side that is across from my right angle is always my hypotenuse. So we can label that side that's marked as 14 as our hypotenuse. And then we also want to look at the side with x because that's what we're solving for. Right. So x is the opposite of that 63-degree angle, so we know that our x side is the opposite side here. Lastly, we've got our adjacent side. That doesn't give us any information, but we can still mark it off or label our diagram. So step one is complete. We've labeled our diagram. Step two says that we want to pick the sides that we need to use. Right? So of our adjacent, opposite, and hypotenuse, right, we want to pick the two sides that give us information in this diagram. Right? So of these three sides, we know that the adjacent side isn't going to give us any information, and we know that the hypotenuse has a length of 14, and our opposite side is marked with x, which is what we're trying to solve for. Right, so the two sides that we're going to want to use are these opposite and hypotenuse sides. Our third step says that we want to use SOHCAHTOA, which is that trig ratio, to decide which one we're going to use. Right, so when I look at SOHCAHTOA, right, this acronym here tells me which ratio uses which sides according to our triangle. Right? If we're picking the opposite and hypotenuse for the sides that we're going to use to solve, right, we know that sine is going to be the best option here because my sine function uses opposite over hypotenuse. Okay, so we are going to want to use our sine ratio on this one. And then our last step, once we know which ratio we're using and what sides we're going to use, we want to set up our proportion and solve, rounding our answer to the nearest hundredth. So when we set up our ratio, right, yesterday we used the trig ratio of sine, right? Instead of putting in a letter here where we identified our angle, we're now going to want to use this 63 degrees that's marked in our diagram. Okay? So since I know the measure of the angle, we're going to say that the sine of the angle that is 63 degrees is equal to the opposite side length, which is labeled as x, over the length of the hypotenuse, which is 14. Right, so again, x over 14 is that opposite over hypotenuse ratio. In our last step, we are solving for x. So just like we would if we had a regular or one-step equation here, where I just had a number on the left-hand side, we're going to solve for x or get x alone on the right-hand side of the equal sign the same way that we've done before. Right. So if I'm looking at the right side, I've got a fraction x divided by 14. Right. If we want to get x alone on both sides, or on the right side, we are going to multiply both sides by 14, right? Because that gets x alone and it undoes that division. Right. 14s would cancel out here. Okay. So 14 times sine of 63 is equal to x. Okay. So when you plug this into your scientific calculator, you should be able to type in this right side of the equation is exactly how it's written. Right, so I'll type in 14, I'll have a set of parentheses that open, I'm going to hit my sine function button, 63, and then make sure I close out those parentheses, right, because that represents 14 times the sine of 63. The last thing that you want to remember is make sure that your calculator is in degrees. All right, so I'll make that note on the side here. All right. When you type this into your calculator, 14 times the sine of 63, making sure that your calculator is in degrees, you should get that the side length is equal to 12.47. Okay. And we were asked to round this to the nearest hundredth, which is 2 decimal places. So I know that x, which is the side length that we were solving for, is 12.